Today we will discuss very important topic, that is types of organic reactions. Organic compounds mainly consist of carbon atoms. Essential element is carbon. It mainly contains carbon-carbon bonds. The nature of reaction, the nature of product, nature of reactant, both responsible for the description of types of organic reactions. Organic reactions, type of organic reaction depends upon the reagent used for the particular reactant and what are the nature of product. If you compare the nature of reactant, nature of product, then we can say what is the nature of reaction, what type of reaction it is. Generally, organic compounds is a covalent compound, so the breaking of carbon-carbon bonds mainly responsible for the formation of the product. If you see the types of bond breaking in organic compounds, in organic reactions, mainly two types of bond breakage takes place. Two types of bond breaking generally occurs in organic reactions. Types of bond breaking. Types of bond breaking. Generally, two types of bond breaking. One is homolytic. Breakage. Second one is heterolytic breakage. These two types of bond breaking takes place in organic compounds, organic reactions. Homolytic breakage and heterolytic breakage. If you consider that organic compounds, suppose made of let it be AB, it is a covalent bond. When this bond breaks homolytically means the bonded electrons, these bonded electrons divided equally with the help of heat or light. Presence of heat or light, this covalent bond breaks uniformly. That means the bonded pair of electrons, the shared pair of electrons divided between two bonded atoms, so that it produces equal species, equal type of product form. Here, the bonded electrons contain it has two bonded electrons and equally divided, so each atom contains a single electron. That's why it contains unpaired electrons. As it contains unpaired electrons, these are called free radicals. So, this type of breakage equally divided, the bonded electron equally divided between the bonded atoms and forming free radicals with the help of light or heat is called homolytic cleavage. It is called homolytic breakage. Formation of free radical. What are free radicals? Having unpaired electron due to breaking of covalent bond, homolytic, equally the bonded electron becomes shared between the bonded atoms. So equally distributed the bonded electron between the bonded atoms. So forming free radical. This type of breaking is called homolytic breakage. Then if this bonded atom, if the bonded electron taken by one atom, so A becomes A plus and B becomes B minus. Here what happens? The bonded electron taken by one atom. Here the bonded electron distributed by both bonded atoms, equally distributed. But here the shared pair of electron, the covalent bond which is formed between A and B by the sharing electron, these two electrons shifted to B. Because B is more electronegativity than A, so it takes all bonded electrons, so it become B become minus, A become plus. The formation of cation anion is formed. This type of breaking is called heterolytic. Heterolytic breakage. But here A plus and B minus, A plus means electron deficient and B minus means electron rich. A plus, this is called electrophiles. This is called electrophiles because electron deficient, and this is called nucleophiles. So two types of reagents are produced from the covalent compound by breaking of a bond heterolytic way. Where it breaks in heterolytic manner, then produce both cation and anions. Cations are called electrophiles, anions are called nucleophiles. Nucleophile means electron rich and electrophiles means electron deficient. So these two types of substances are produced. These three substances generally electrophiles, nucleophiles or free radicals. These three all are called electrophiles, nucleophiles and free radicals. Here electrophiles is electron rich, electron deficient. This is electron deficient, and nucleophiles electron rich, and free radicals, as it has unpaired electrons, it demands another electron to form pair electrons. That's why it is also electron deficient. So three types of species are formed. Combined, these are called attacking reagent. These are called attacking reagent. What is attacking reagent? Generally, these type of reagents generally initiate the reaction. With the help of these reagents, the reaction takes place. Organic reaction mainly takes place with the help of these three reagents: electrophiles, nucleophiles, and free radicals. Electrophiles electron deficient, nucleophile electron rich, and free radicals also electron deficient. Free radicals sometimes called as also electrophiles because it is also electron deficient. Because why electron deficient? Because it has unpaired electron, it has demands another electron to form pair. So this is called also electron deficient. So these are called attacking reagent which initiate the reaction. With the help of this reagent, organic reaction takes place. So on the basis of involvement of electrophiles, nucleophile and free radicals, organic reaction can be divided into different types. So what are the organic reactions? Let us discuss. First one is substitution reaction. Substitution means that is replacement of one in place of another. Substitution of one in place of another, that is called substitution reaction. But what type of substance is substituted in organic compound, that is very important. On the basis of the type of reagent substituted in the organic compound, are different types. So in substitution reaction, one atom or group is replaced by another. Maybe hydrogen replaced by other, maybe other group replaced by another group, maybe hydrogen or other different types of group, but it is called substitution. But what is substituted, that is very important. On that basis, it is different types. Substitution reaction may be free radical substitution. In free radical substitution, what happens? Free radical is substituted. For example, this is your methane in presence of chlorine and light and produce CH3, Cl and HCl. Here free radical is Cl dot. Here 2 Cl dot is formed first. This Cl dot produced from Cl2 by the help of light gets substituted in CH4. So one H is removed and one Cl dot is replaced. That's why it is called free radical substitution. Here free radical is substituted in place of hydrogen. That's why it is called free radical substitution. For example, you can tell like this. Suppose CH3, CH2, CH3 plus Cl2 in presence of light produce CH3, CH, Cl and CH3. This is the major product. Because this hydrogen is more reactive than this is called your this position primary. This is primary carbon. This is your secondary carbon. This is your primary. Primary carbon means which is attached to one carbon. That is called primary. And this is secondary because it is attached to two carbon. If carbon atom attached to another two carbon, that carbon is called secondary. If attached to one carbon, that is primary. It is also primary. It is primary. Secondary hydrogen. Secondary carbon. So hydrogen attached to secondary carbon generally more reactive. That's why fluorine, this free radical gets substituted in secondary position, not in primary. That's why it is major product. This is very important. Why not CH3, CH2, CH2Cl is produced? Because this hydrogen is less reactive than this carbon. Because this hydrogen is more reactive hydrogen. We will discuss in the next class regarding the stability of free radicals. We will discuss next another lessons. But here, this remember, secondary hydrogen is more reactive than primary. Similarly, tertiary also more reactive than secondary. Similarly, so this is the substitution takes place at second position, not in first position, due to reactivity. So this is called free radical substitution. Then electrophilic substitution. This type of reaction mainly takes place in aromatic compounds. Suppose this is your benzene, aromatic compound having pi electron cloud, reacts with chlorine in presence of benzene reacts with chlorine in presence of ferric chloride. Here ferric chloride reacts with chlorine forming electrophiles. Here electrophiles is plus because carrying positive charge. Here Cl plus is produced from Cl2 with the help of ferric chloride. And this Cl plus called electrophiles is substituted in benzene forming chlorobenzene. This is called one electrophilic substitution. Electrophilic substitution can take place in depends upon the nature of the group attached to the benzene. We will discuss in the next lesson. But remember, electrophilic substitution reaction means electrophile substituted in aromatic position where electrophiles means who is generally attraction towards electron. Here electron means pi electron cloud. So towards pi electron cloud, electrophiles will be attracted. This will be attracted, and due to presence of pi electron forming chlorobenzene. So this is called electrophilic. So many examples are nitration also takes place. Benzene ring plus nitric acid and sulfuric acid mixture forming which electrophiles NO2 plus. You produce NO2 plus and gets substituted in benzene forming nitrobenzene. Here NO2 plus adds electrophiles and Cl plus also acts as electrophiles. So forming what? Nitration. This is called nitration reaction. This is called halogenation. Attacking of Cl plus. Here attacking of NO2 plus. Both are electrophiles. So on the basis of attacking reagent, this is called free radical substitution. This is called electrophilic substitution. Then another is nucleophilic substitution. Nucleophilic substitution is Here nucleophile gets substituted. For examples, CH3 Cl plus KOH. Here KOH means here OH minus acts as nucleophiles having negative charge and attack to the carbon positive charge. Carbon plus, chlorine minus. Carbon is plus, chlorine is minus, that's why OH minus attack to CH3 forming CH3OH plus HCl. And this reaction is here attacking of OH minus, that means nucleophile, hence it is called nucleophilic substitution because here OH minus is substituted in place of Cl. That's why it is a nucleophile. That's why it is called nucleophilic substitution. So many types of nucleophilic substitution we will discuss in different chapters. So just you know that on the basis of attacking reagent, we can say it is nucleophilic substitution, electrophilic substitution, and free radical substitution. Electrophiles may be positive charge or may be also neutral, having electron deficient. So let us discuss electrophiles, different types of electrophiles. Electrophiles may be positive, that is your R plus, Cl plus, NO2 plus, H plus, like this. These are called electrophiles. And neutral species having vacant orbitals, that is your BF3, AlCl3, AlCl3, BF3, it acts as also FeBr3. These are acts as electrophiles because these are electron deficient. Electron deficient species also electrophiles and carry positive charge also called electrophiles. So these are electrophiles. And nucleophiles, electron rich, that means carrying negative charge. For example, H minus, OH minus, Cn minus, RO minus. These are called negative nucleophiles having negative charge. But some compound neutral species also acts as nucleophile having electron rich, that is having lone pair, NH3 having one lone pair, water having two lone pair, alcohol having two lone pair, amine having one lone pair. So these are also acts as nucleophiles. So remember what are the electrophiles, what are nucleophiles. Electrophiles are electron deficient, nucleophiles are electron rich. On that basis, these are some neutral species, these are also neutral species, these are the cations, these are the anions. So what are the electrophiles, what are the nucleophiles? On the basis of substitution are free radical substitution, electrophilic substitution and nucleophilic substitution. Then similarly, that is addition reaction. Addition reaction may be also on the basis of addition of the particular reagent. It is of the three types, that free radical addition, reaction. What are the free radical addition? Here free radical is added. Addition reaction means we know double bond convert to single bond or triple bond convert to double bond. Here CH2 double bond CH2 plus Cl2 gets added in presence of carbon tetrachloride forming CH2 single bond CH2 Cl and Cl. This is free radical. Here free radical gets substituted, that Cl dot. This reaction. So this is called free radical addition. Then other example you can take also CH2 double bond CH2 plus H2 in presence of nickel and heat producing CH3 ethane. That is also one free radical addition. Then nucleophilic addition. In nucleophilic means nucleophile will be added. First nucleophile will be added. For example, here CH3, C double bond O in presence of hydrogen cyanide. Here hydrogen carry plus charge, Cn carry minus charge. Here Cn minus attack, then double bond breaks. So CH3, C, then Cn single bond OH, then H will be added to O minus. So formation of this, as double bond breaks is a single bond, it is the addition reaction, and attacking of nucleophile first, Cn minus attacking to, because carbon carry plus charge and oxygen carry minus, because oxygen is more electronegative, so carbon takes Cn minus. As Cn minus is attacking towards carbon double bond, that's why it is nucleophilic addition reaction. Similarly, that electrophilic addition, in electrophilic addition generally takes place. Electrophile first, suppose CH2 double bond CH2, CH2 double bond CH2 plus HBr. Here electrophile is H plus and Br minus. As it has electron cloud, electron source, so first H plus attack. As H plus is attacking to pi bond, because pi bond is electron source and H plus electron deficient, that's why electrophile. Electrophile is attacking and double bond breaks, forming CH3, CH2, Br. As double bond is breaking, that's the addition reaction. As H plus is attacking first. Why H plus is attacking? Because H plus electron deficient, double bond means electron rich. That's why it is called electrophilic addition reaction. So we can take another example. It depends upon nature. CH3, CH double bond, CH2 plus HBr. Product will be CH3, CH, Br, CH3. This is the major product. This is the major product. We will discuss in the next lesson that depending upon the formation of reactive species, here H plus attack and produce more stable species. That's why the Br minus attack to middle carbon, not in first carbon. We will discuss that is it has a rule that is called Markovnikov's rule. We will discuss in the next lesson. But this is what we are mainly discussing. We are discussing on what basis the types of organic reaction may be. If nucleophile is added, it is called nucleophilic addition. If electrophile is added, that is electrophilic addition. Okay? Then next is elimination reaction. In elimination reaction, it may be alpha elimination. Alpha elimination means the group will be removed from alpha carbon. Suppose this is your CHCl3 and you attach to OH minus, that is base. Here what happens? OH minus takes H, forming from, this is the alpha carbon, because first carbon attached to functional group, that is alpha. Chlorine is a functional group here attached to that carbon, that is alpha. First carbon attached to functional group is called alpha. So H is relieved from alpha carbon. This is called what? Alpha elimination. After loss of H becomes C minus, and OH minus H become water. So it is called alpha elimination. Loss of hydrogen from alpha carbon, that is called alpha elimination. Then beta elimination, it is also called as alpha beta elimination. Alpha beta elimination it is also called. For example, CH3, CH2, Br in presence of alcoholic KOH. Alcoholic KOH is generally creates loss of group halogen from the group. So here this is alpha, this is your beta. So loss of hydrogen from beta, loss of bromine from alpha. That's what is called alpha beta elimination. As it is produced from second carbon, that's it is specific, it is called beta elimination. Or it is also called as alpha beta elimination. So forming CH2 double bond CH2 plus Br minus KBr and H and OH minus, that is water. So formation of water, formation of KBr and alkene is produced. This is elimination. Elimination means formation of double bond, triple bond from the single bond. That is called elimination. Already you know this one. So this is called beta elimination. And the group of product, suppose CH3, CH here Br, then CH2, CH3. Here it undergo the same alcoholic KOH. Here elimination mainly prefer at this position. We will discuss in the next class. That is, this elimination is more preferable elimination. This is the major product. Not from the, this is alpha, this is beta, this is your beta. Alpha means functional group, first carbon is alpha, beta. So when hydrogen can be removed from beta carbon from here, but from this carbon is the major, because this product, substituted product, alkyl substituted product is more stable product. This rule generally we will discuss later, that is Set-Zepf rule. This is called Set-Zepf rule, more stable product. And this addition reaction, that is electrophilic addition that we are discussing, that is based on Markovnikov's rule. This is called Markovnikov's rule. This is Markovnikov's rule. We will discuss in the next class, next lesson we will discuss, this thing will be repeated. But we are not discussing the types of reaction, that what is the main type of reaction. Mainly it is on the basis of what attacking reagent is used. Here as hydrogen removed from beta position, that is beta elimination. If removed from alpha position, that is alpha elimination. Then gamma elimination. In gamma elimination means mainly it will remove from gamma elimination is also called as alpha gamma elimination. It is also called alpha gamma elimination. For example, you take CH2, here bromine. If heat this in presence of zinc and heat, then produce CH2, this cyclic product. So this is alpha, already I have told you, that is functional group alpha, beta, gamma. So bromine removed from alpha position and gamma position. That's what is called alpha beta combination. That is your cyclopropane. Mainly cyclopropane is formed. This type of elimination is called what? Alpha elimination, gamma elimination, or beta elimination, on the basis of the hydrogen or the group removed from the particular carbon. Carbon may be alpha, beta, gamma on the basis of the attached to the functional group. The first carbon attached to functional group is alpha, second is beta, gamma, delta, like this. But alpha, beta, gamma is very important because the reactivity mainly depends upon first three carbon. First carbon, second carbon and third carbon. That's why mainly it is used as alpha, beta and gamma elimination. On this basis, so types of reagent used: free radicals, electrophiles and nucleophiles, addition reactions, elimination reactions, and here also substitution reaction. These are called as different types of organic reaction. Besides this organic reaction, some another important organic reaction may be discussed. You complete this one. Next one is the rearrangement reaction. Here the group in the same group, the one place it is occupied by another place. So the group is occupied from one place to another place, but the formula remaining same. For example, this type of species, you can say, so this type of species, it is also one type of electrophiles having positive charge, but this is called carbonium. We will discuss next. Carbonium. Carbon carrying positive charge is called carbonium. It is one type of carbonium, but this carbon is primary because primary carbon carry positive charge. This carbon is primary. It will be rearranged. This will be shifted to this side. This is called migration, alkyl migration or alkyl shift. You can say alkyl shift. Here CH3, now CH3 attached to C carrying plus charge, then become CH2, CH3. This is now tertiary because this carbon is tertiary. 1, 2, 3. Here this carbon is primary, only directly attached to one carbon. So this carbon attached to 3 carbons, so it is tertiary. It is more stable. It is less stable. Primary is less stable, but tertiary is more stable. So this type of shifting of one group or one atom to another position, forming more stable product, that is called rearrangement reaction. Rearrange, express. Also, we can take another example, that CH3, CHO, This compound can be rearranged to CH2 double bond CHOH. Just to see, here having single bond and double bond, but group is same. There is no difference in the formula. CH3CHO means 4 hydrogen, 2 carbon. 2 carbon, 4 hydrogen, remaining same, 1 oxygen. But only here H is shifting from this to this position. This is also one example of rearrangement. So, on the basis of nature of reactant and product, organic reaction are different types. What type of attacking reagent is used, then we can divide the organic reaction accordingly. That is involvement of group in substitution reaction. It may be free radical, electrophilic or nucleophilic. Addition may be free radical, nucleophilic, electrophilic, and your elimination atoms or group will be eliminated from the carbon atom, from the same carbon or the adjacent carbon. So it depends on alpha, beta, gamma position. So alpha elimination, beta elimination, gamma elimination. So these are some fundamental concepts regarding the types of organic reaction. Besides this, organic reaction may be polymerization, may be that we can say that isomerization also. But this is the part we will discuss. In the particular part we will discuss in the particular reactions. But these are the very fundamental concepts regarding the types of organic reaction. If practice, any doubt you have, we can discuss in the next class. Okay, thank you all.